All right, so we're going to go through the review sheet for your test tomorrow. I'm going to go through as quickly as I can. If you have more questions, feel free to give me a call or come in the morning and ask. Or if you have me after lunch, you can ask during lunch. So, which scatter diagram shows the strongest positive correlation? Well, positive correlation means you want something that is close to a line. So, the two that are close to lines are this and this, so 1 and 2. 3 and 4 aren't really correlated very well at all. And the other important part is that it says the strongest positive correlation. So you want something that has a positive correlation. In that case, it would be choice. That is not what I wanted to use. It will be choice 1, because it has a positive correlation and it's pretty linear. Number 2, a linear regression equation of line of best fit between a student's attendance and the degree of success is h equals 0.5x plus 68.5, and it says the correlation coefficient would be what? So you want to ask yourself, what is the graph of this going to look like? So if I had a graph, we know that it'll be 0.5 plus something, so it'll be something like this, because our slope is a positive 0.5, so we know it's going to be positive. Right away we can get rid of this. We know that there is some kind of correlation, so we can get rid of this. And this also here includes the negative, so we can get rid of that. So your answer for this would have to be choice 1. You don't have to do any calculating for that one. It's just thinking about what they're asking you. So if you know that your graph looks something like this here, you will be able to tell which one the correlation coefficient will be. The next one, from 1984 to 95, the winning scores for a golf tournament were as follows. And using these, we want to find the sample standard deviation and then find out what percent score within one standard deviation of the mean. So we're going to go over to our camera here. And you're going to have to go in and push stat, go into your edit, and as you'll see, I already have all of them in the list there. So what I want to do from here is go ahead and push stat again, go over to calculate, and I want my one variable statistics. So it brings up all of my statistics here. So we need to know what the sample standard deviation is. So you'll notice that the sample standard deviation, SX, is about 3.15. So our sample standard deviation, SX, is about 3.15. Oops. So using that, we want to find what percent are within one standard deviation. Well, you'll also see that the mean right here is 278.6 about. So our mean, the middle number, is 278.6, and we want to go one above. So you want to do 278.6 plus our standard deviation, which is 3.15, which gives me 281.75. And you also want to do 278.6 minus 3.15 and see what you get. And that'll give us 275.45. So now you want to ask yourself, which of our numbers are between 275.45 and 281.75? So you'll notice up here that we have 1, 2, 3, 4, 5, 6, 7. 282 is not. 285 is not. 272 is not. 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that will be 9 out of 12, which if you divide that out actually gives you 75%. The next question, if Bill's test scores are 78, 92, 82, 86, and 90, the range, well, for the range you're going to take the highest, which is 92, and you're going to subtract the lowest, which is 78. 92 minus 78 is 14. So our range here is going to be 14. Using the table of data below, find the mean, mode, median, and range. So we want to go ahead, back over to our calculator. We want to go into our stats, edit, we want to clear out what we had in there before, and we want to enter in 80, 85, 90, 95, and then we want to go ahead in the other list and enter 5, 7, 9, and 4. And we want to go into statistics. We still want the one variable stats. Oops. One variable stats. And we need to remind the calculator that we want list 1 and list 2. And it will bring up our information here. So we know right away, it tells us that our mean is 87.4. Our mode is the one with the most frequency. So the highest frequency is 9. So that would be 90. Our median, if we scroll down here, is going to be 90. And our range, if we subtract 95 minus 80, we'll get 15 for our range. The interquartile range, well, we know that Q3 is 90, so it's going to be 90 minus quartile 1 is 85, so that's going to be 5. And our standard deviation to the nearest tenth, we look up here, we want to do the population standard deviation because we're talking about everything, so that little crazy O to the nearest tenth would be about 4.92. Variance is going to be that number squared. So this is the one where you push math. Oops, nope, sorry. You push vars. You go down to statistics. You find the little crazy OX, and you square it. Now you could also type in the whole variance, 4.92341345, and square that. But this is easier, and we end up with, to the nearest tenth, 24.2. The mean absolute deviation is a little trickier. This is the one where you make the table, and I'm not going to go through the whole thing just for sake of time. Where you put your x, you put your x bar, you subtract them, so it's going to be x minus x bar, and takes the absolute value of it. So I'll do a couple of them here. So let's say we have 80, and our mean is 87.4. If you subtract those, you get negative 7.4, and the absolute value would be positive 7.4. And in this case, when you do the frequency times that last column, so in this case, it will be 5 times 7.4, which ends up being 5 times 7.4 is 37. So that gives you 37 there. Okay, and you would do that for the rest of these all the way down for 85, 90, and 95. You would add them all up at the end and then divide by, we end up with, when you add these up, you end up with 14, I believe. Oh, sorry, 25. You end up with 25, so divide it all by 25. If you need help with that one, feel free to come in or give me a call. The next question. On a standardized test, the mean is 68 and the standard deviation is 4.5. So I'm going to go ahead and fill in right away that my middle number is 68 and my standard deviation is 4.5. So I want to put 68 plus 4.5 is going to be 72.5. So that's one whole up is 72.5. Okay, if I go another one up, so plus another 4.5, so now I'm 2 standard deviations up, I'm going to be at 77. If I go below now, so I take 68 and I subtract 4.5, 1 standard deviation below is going to be 63.5. and 2 standard deviations below is going to be 59. So they're asking you what percentage of scores fall between 59 and 77. So from 59 all the way up to 77, they're asking for all of this data in here. All of that. So you need to go ahead and add up 4.4, 9.2, 15, 19.1, 19.1, 15, 9.2, and 4.4. And when you add those all up, you actually end up with 95.4%. Okay, so that is your answer, 95.4%. Next question. In a certain school district, the ages of all new teachers hired are normally distributed. Within this curve, 95.4% of the ages, centered about the mean, are between 24.6 and 37.4. Well, it really helps that we know that if you add all of these up, you end up with 95.4 from the last problem. So we know right away that 2 standard deviations below is going to be 24.6, and 2 standard deviations above is going to be 37.4. So if you want to find what your average is in here, and we want to find what the standard deviation is, you're going to go ahead and subtract 37.4 minus 24.6, and that will give you something like 2.8. And you will notice that this is 1, 2, 3, 4 standard deviations. Sorry, that's 12.8. So then you do 12.8 divided by 4, which gives us 3.2 as our standard deviation. Okay. If you want to find your mean now, your x bar, you would do 24.6 plus 3.2, which gives you 27.8, plus another 3.2 is going to give you 31. So your x bar is going to be 31. And the really neat thing is that if you added another 3.2 on again, you'd end up at 34.2, plus another 3.2 will get you right to that 37.4. So we know we did it right. That one is a little tricky. We only did a couple examples like that. So if you need help, again, always ask. 2 social studies classes took the same current event examination based on 100 points. One of them got a median score of 78 and a range of 4. The other one also had a median score of 78, but this one had a range of 22. How could they have the same median but different ranges? Well, as you know, the median is just the middle number. So that means that there's a certain number of data before it and a certain number of data after it. So if that median is the same, but your numbers are more spread out, as long as there's the same number on one side and the same number on the other side, the range here going from lowest to highest and the range here going from lowest to highest can be very different. So you need to write down something like that. The median is just the middle. It's not a measure of variance, it's just a single measure of central tendency. A set of normally distributed student tests has a mean of 80, so we're going to go ahead right away and write 80 in the middle there, and a standard deviation of 4. We want the probability that a score will be between 74 and 82. So 80, if we go 1 standard deviation above, is going to be 84, so we're already past where we need to be. So if we go to a 0.5 of a standard deviation, halfway in between those, we would have 82, which gives us our 82 here. We want to go the other way to get to 74, so 1 standard deviation below would be 76, and if you can't tell already, to get to this 1.5, that would actually be where our 74 lies. So we want to go ahead and add up everything from here all the way up to our 82. So all of this data in here. So that's going to be 9.2 plus 15 plus 19.1 plus 19.1. And when you add those up, it actually gives you 62.4%. So the probability would be 62.4 out of 100. In a mathematics class of 10 students, the teacher wanted to determine a homework grade influenced subsequent test grades for each student. This is given in the accompanying table, okay? So if we go back over to the calculator and we go ahead and go right into our stat edit, you'll notice that I have all the information in there for us already. So then I want to go and see what it says. Given the equation of a linear regression line for the set of data. So this is the one where we want to go ahead and push stat, go over to calculate, and we want to get our linear regression here. So we hit enter. Now remember, if you don't have the R's there, you need to go in and turn on diagnostics through the catalog button. So in this case, it says A is about 0.834 and B is about 14.6. So for our first question there, the linear regression for this set of data would actually be y equals, our A is about, let's say, 0.83 x plus 14.6. So there's our linear regression. A new student comes to the class, and we want to know what would a homework grade of 78 give you. So you're actually going to go ahead and plug 78 into our equation right here. So you're going to take about 0.83 times 78, and then you're going to add 14.6. And that'll give us a score of 79.34. So for that second one, 79.34 is what we end up with. I'm sorry that's in the margin there. I apologize. All right. The next question. Local high school would like to have a stoplight near the school crossing, but the town council decides it needs more information. So we want an unbiased sampling for a stoplight near a school. So do we want to question the parents dropping kids off? Probably not. They're going to be biased because, yeah, they want their kids to be safer. Telephone a random group of homeowners. That sounds like it might be a good idea. You'll get a pretty good sampling. And anytime you see the word random in there, it's usually a pretty good descriptor. Hold a school meeting on the issue. Again, you're going to get a lot of the parents from number one to come to that. So I think that's probably biased. And ask owners of local stores. Well, I would think that they probably would want as much traffic going by as possible. So they want less stopping on the road. So they would be biased also. So in this case, 2 would be our best choice. The owner of a company tells the employees that the median salary, so the middle number, is $41,000. He doesn't tell them that he is the only person receiving the top salary of $150,000. If he raises this up to $200,000, too many commas in there, up to $200,000, which is true, the median salary would not be affected. Well, again, that's the median. We got rid of this one and put this in its place. So the median will not be affected. Actually, that is going to be probably the best answer, but let's look at the rest of them just in case. The median salary would be increased. Well, median is not influenced by higher or lower numbers. It's just the middle all the time. So that's not the answer. The mean would not be affected. Well, if you raise something $50,000, the average salary is probably going to go up. And the mode would not be affected. Well, we don't know that. If there's no other double ups in there, the mode wouldn't be affected, right? It would be only if there was a double somewhere else that would not be true. So this might actually also be a good answer, but the best one, for sure, in my opinion, is going to be choice 1. Last question here. Every score in a test was raised by 10 points. Which of the following would not change? Well, if you raise everyone's score by 10 points, the average is going to change. So that's not the answer. If you raise everyone's score by 10 points, the median is also going to be 10 points higher. The mode, whichever one shows up the most, is going to be 10 points higher. But the variance, how spread out the data is actually going to stay the same. Because that's measuring how far spread out the numbers are. And it doesn't matter if the numbers are here or if the numbers are higher up on the number line, they're going to be spread out the same, they're just all 10 points higher. So choice 4 is going to be your best answer. Again, as always, if you have any questions, feel free to give me a call, shoot me an email, or stop in the morning. Other than that, good luck studying, and I will see you tomorrow.